The complex and intricate food webs of an eelgrass meadow rival the world's richest farmlands and tropical rainforests. From an unstructured, muddy, sandy bottom grows a myriad pattern of leaves that supply nutrients to salmon and other fish, shellfish, waterfowl, and many, many species of faunal invertebrates. This video is about restoring these rich habitats on the British Columbia coasts of the Salish Sea and western Vancouver Island. As the diver swims above the seafloor, their fins are always positioned upwards so that as they swim near eelgrass, they do not disturb the plants, the sediment, and the marine life living in the habitat. After a habitat survey has been completed of the nearshore and shoreline features, underwater visual survey is done of both the eelgrass donor bed and the potential transplant site. The diver will first examine the density and health of the eelgrass in the potential donor site. The diver is examining the blades for the presence of wasting disease and assessing the length and width of the blades to determine the ecotype of the donor bed so that it is the same required for the transplant site. As the diver swims above the transplant site, they are taking note of any potential problems, such as the presence of rock reefs that might encourage Japanese wireweed or Sargassum mudicum to overshadow eelgrass, or the abundance of mobile woody debris that might inhibit the expansion of newly planted shoots, or signs of boat moorages, such as cement blocks, or an abundance of crab species that would enthusiastically welcome eelgrass as shelter to burrow into. Both the donor site and the transplant site should be growing in similar conditions, such as the same depth, same current regime, same orientation to prevailing winds, and same type of substrate. The diver measures the area suitable for this transplant and calculates how many shoots would be needed if they were to be planted at 10 shoots per meter squared. The diver is also examining the sediment to make sure it is loose and is suitable for the expansion of eelgrass rhizomes. The diver then ascends and records additional notes in a logbook. Once the donor bed has been chosen, the diver will harvest plants by hand or trowel. Healthy eelgrass is collected using careful techniques to minimize damage, ensuring the plants remain intact and viable for transplanting. It is vital to remove the individual shoots out of the sediment gently, without breaking the rhizomes too short. Shoots need rhizomes with a minimum of 3 nodes to survive. If collection of shoots with proper rhizome length is not possible, it is best to choose another harvesting site with looser sediment. Never harvest more than 10% of the eelgrass donor bed. One shoot is taken and the diver kicks away to the next harvesting site to ensure space between harvest areas. The rule of thumb is 1 shoot harvested per square meter, so that there are no bare areas after harvesting. After a handful of shoots are collected, the diver will place them in a nylon mesh collection bag, making sure the clasp is secure before swimming to the next location. When the collection bags are full, divers ascend. The harvested eelgrass in saltwater-filled tubs are delivered to the shore crew, who are positioned at workstations, configured to make work efficient and comfortable. It is important to keep the chutes submerged at all times, except when the anchors are being attached to the rhizomes. Each chute is checked to make sure 3 nodes are attached to the plant. Extra rhizome is removed. Each chute is then attached to an ungalvanized washer above the nodes in the pale white part of the plant. And placed in a fresh saltwater-filled tub situated between the tires. These washers and twist ties ensure the chutes are well situated in the sediment until their roots are able to act as stabilizers. They degrade over a short period of time. When there are enough tied chutes, they are grouped in clusters of 10 and strung together into a string or necklace on biodegradable jute or hemp string by another group of crew members. Clusters are then placed in laundry baskets within fresh saltwater tubs. If the workstation is near a shallow, calm area, the baskets are transported to the shallow water and submerged, with an eye on the tides so they do not become exposed or drift away before being picked up by the divers. If the crew is not close to the near shore, the baskets can be placed on land within the water-filled tubs and covered with a lid to protect them from exposure. Setup of transplant site. An equipment list is included in the appendices of the Restoration Handbook for this stage of the transplant. The diver measures the depth of the transplant site constantly and also the dimensions of the site for future reference. When the endpoints are determined, the diver places copper tubing or rebar at each end of the measuring tape. The depth is checked to make sure the depth gradient is constant as the diver traverses the transect or measuring tape. Marker floats are placed at the end of the transect, and GPS marks are taken from the surface. The marking stakes are temporary, as over time, if left in place, they can collect sediment and ultimately damage the transplanted shoots. The site is ready for a transplant at 10 shoots per meter squared. Double density of shoots are sometimes used, 10 shoots per half a meter squared, if it is determined that the site has particular challenges, such as high velocity current, loose debris on the sediment, or any disturbance nearby, such as boat traffic lanes. Baskets of prepared chutes are gently dropped near the transplant site from the side of the boat. The diver below transports the baskets to the transplant site, adjusting buoyancy for the added weight. About 3 or 4 bundles are lifted from the basket and brought to the 0 mark on the measuring tape. The diver makes sure each bundle is not tangled and the chutes are facing upwards. Each bundle of 10 are placed 1 meter apart. Because sediment can be very loose and silty in areas where transplants take place, it is important to place the bundles accurately so that when the silt arises in the water column and visibility is limited, the diver knows the distance between chute bundles is accurate. This helps with monitoring the transplant 6 months and 1 year after planting, as the original planting design will be compared to the changed pattern of growth over time. After all the bundles are placed in position, and depending on the looseness of the sediment, the diver can either use a trowel or gloved hand to dig a hole approximately 6.5 centimeters or 2.5 inches to place the bundle of 10 chutes. After covering the rhizome and patting down the surrounding sediment, the diver combs the blades to make sure they are not entangled. After all the bundles are planted, the diver checks each one to ensure proper burial and for upright blades. Shortly after the diver returns to the boat, it is important to create a sketch map of the transplant site for documenting the exact location of the site and for a drawing of the planting design. After laying down the measuring tape along the length of the original transplant location, the diver takes notes of the density and notes other measurements of a patch of eelgrass randomly selected. The quadrant is randomly placed within the transplant area. It is best to use a 1/4 meter squared or 50 centimeter by 50 centimeter aluminum quadrant. A minimum of 30 monitoring samples are taken if the transplant bed is large enough. The eelgrass is transplanted at a rate of 1 cluster or patch of 10 shoots per meter squared. It usually takes 2 or 3 years for them to multiply enough to coalesce. Therefore, the success of the transplant can be monitored before that time by counting the number of shoots per patch. It is important to note the new shoots at the base of the parent plant and to include them in the density count. It is very helpful and informative to monitor a reference bed or a natural eelgrass bed nearby growing at the same depth as the transplant to observe how the transplant compares to it. Take note of the marine life observed on the shoots or seabed or swimming nearby. Restoration of eelgrass is challenging, especially in times of climate changes. Over time, however, a small area of restored eelgrass can grow into a meadow, healthy habitat for salmon and all life they depend upon. Never give up, never surrender.